Chapter 2, Part 1. You can refer to the lecture notes today by accessing the Canvas and then go to Module, then go to Week 3, Learning and Teaching Materials. Right? So for this class today, I'm going to introduce to you the basic concept of probability. Alright? So this chapter today is important. If you miss, then you may not be able to follow the following class later. So the first is I will have to understand what is the meaning of probability. Probability means the chance of an event occurs or the chance of activity happens. And usually we use P or PR to represent probability. You can use P or PR. Both can be used to represent probability. You can use P or PR. Both are accepted. This is the symbol we use to represent probability in statistics. So if you want to calculate the probability of event A happen, let's say you want to get probability for event A happen, then what is the formula that you can use? You can use this formula, right? It's equal to number of elements from event A divided by number of elements from the sample space. Okay. So let's try one example. Let's say we have one experiment. Okay. Experiment is we want to throw a die. A die, this is our experiment activity. Okay. We want to throw a die. Then we want to know what is the probability of obtaining odd number. Odd number means the number that cannot be completely divided by 2. Odd number. Odd number means number that cannot be completely divided by 2, such as 1, 3, 5, 7, 9, 11, 13. Okay? These are odd number. Odd number are the number that cannot be completely divided by 2. So, how about even number? Even number are the numbers that can be completely divided by 2. Okay? Such as 2, 4, 6. These are the numbers that can be divided by 2 completely. So we call it as even number. Okay? So today, our first experiment is to throw a die. Then we want to know what is the property of getting odd number. Odd number. So before we can answer the question, we have to understand first the study object. Okay? So this is the sample die. This is not a standard die, but just a toy die, right? So a die consists of how many faces? 6 faces, right? 6 faces. So that means that we can conclude for this event, when you want to throw a die, right? Okay, there will be 6 results. 6 results. The result can have 6 results. If you throw a die, the result can be showing 5, and can show 5, can show 4, 3, 2. So there will be 6 possible results. Okay, so the NS is equal to 6. Okay, one die has 6 faces. So the denominator is equal to 6. Okay, so the question now is asking, then what is the property of getting odd number? Odd number. So how many faces got odd number? Odd number means 1, right? 3, 5. So got 3 faces. Okay, from the dice that consists of odd number. So if you want to calculate property of odd number happens when throwing the dice, so answer will be 3 over 6. Then this fraction number can be simplified. So you'll get 1 over 2. 1 over 2. 1 over 2, if you simplify to percentage number, is equal to 50%. Okay. So 50%, the chance that we'll get an odd number if you throw a die. That's the meaning. Okay. So this formula you need to remember, it's very important. Okay. So bear in mind, the probability of event A must in between 0 to 1. Can be equal to 0, can be equal to 1. Cannot be negative number, cannot greater than 1. Right? So what is the meaning if probability A is equal to 0, let's say? Okay. What is the meaning if probability A is equal to 0? That means event A, guarantee will not happen. Okay. Confirm, 0% event A will happen. What is the probability A is equal to 1? What is the meaning? That means 100% event A will happen. What probability is equal to 0.7? How to interpret this meaning? That means 70% that event A will happen. 70% event A will happen. Okay, alright, next slide. Okay, let's try some examples. So the first example is A. Okay, still the same experiment. We throw a die. We throw or roll a die. Fair die. Fair die. This is not fair die. Okay, I have fair die. Fair die is this one, standard. Okay? This is fair die. So if you throw a die, what is the property? To get score 5. Score 5 or face up. So how to get the result? So you can apply the formula that we learned this morning using this formula. Right. So at first you write down the denominator first. Write down the denominator first. Decide this one, what is the value? 6, right? Why 6? Because the study object now is a die, right? A die in total consists of 6 bases. So the denominator is 6. Okay. Then we have to decide the numerator here. So if you observe, right? How many faces of a die consists of score 5? How many faces got score 5? Only one, right? Only one. So that means numerator is 1. Okay. Then we check, can this fraction number be simplified? No, cannot. This is the simplest form of fraction number. So just leave the answer until here. Okay. Just leave the answer until here. No need to change anything. Because if you leave the answer in percentage number or decimal number, there will be a continuous decimal number, not nice. So just leave the answer here. Okay. Second question. What is the property of getting even number? Even number means 2, 4, 6, 8. These are even numbers. No, even numbers, right? Even number. 2, 4, 5, 6. 2, 4, 6, and also 8. Right? So at first we have to decide what is the numerator. Decide this one. So that this object is die, right? Die consists of 6 faces, so put here 6. Then decide the numerator. Numerator, okay. So from this dice, how many faces consist of even number? 2, right? These 2, 4 here, right? 6. 3 faces got even number. So put here 3. Okay. So this number can be simplified. So it's equal to 1 over 2. So okay? So okay, next. What is the probability that if you throw a dice, the number is less than 5? So this question does not specify the number value, but it must be less than 5. Okay. Less than 5 means cannot equal to 5, not equal to 5. So what are the numbers which are less than 5? 1, 2, 3, 4. So there will be 4 faces which are less than 5 on the score, right? 4 faces. So we substitute 4 to here. Denominator still the same, still 6, because the study object is the same, it's a die. Okay. So simplify, you get 2 over 3. Okay, next question. What is the probability? Okay, if you throw a die, the result you get is equal to 2 and 4. What's the mean? That means there will be 2 numbers appear at top, show you 2 and 4. Is that possible? No, right? You cannot get 2 and 4 at the same time. Right? If you throw a dice, can you get 2 and 4 at the same time? Cannot, right? So n means at the same time. So what is the chance to get 2 and 4 at the same time? Answer is 0%. Right? You cannot get 2 and 4 at the same time. So just put 0. No chance to get 2 numbers by throwing a die. Okay? Okay, next. What is the property? If throwing a die, the number is either 2 or 4. So what's the meaning? What's the meaning of this equation? That means that if you throw a dice, what's the probability there, or the chance? You'll get score 2 or score 4. Okay? Either 2 or 4. That's the meaning. 2 or 4. Right? So in order to solve the problem, we try to do step by step. Okay? We try to solve this one first. Okay? So what's the probability? The die will show score 2. Answer is 1 over 6, right? 1 over 6. So it all in statistics means plus. All in statistics means plus. This is a plus sign. All is plus. Plus. Okay. Then we solve this part. So what if you throw a dice, what is the probability? You'll get score 4. Answer is also 1 over 6. So sum up these two, you'll get 2 over 6. Okay. And simplify, you get 1 over 3. So far, okay? So far, so good? Any questions so far? I stop for a while. Okay, yeah? Alright, next. So this example consists of the survey data, yeah, among the 100 sample chosen, okay, to identify the preferred banks. Okay, so in total we have 100 samples involved in the survey. Okay. And 20 of that, 20 of the customers mentioned that they prefer Bonza Bank. Okay. 26 prefer Combank, 34 prefer Native Bank, and the remaining 20, okay, prefer Not Bank. So altogether we have 100 customers involved in this survey. Okay. So we have 100 data. Okay. So what's the meaning? 100, that means NS for this question is 100. Okay. This will help us what is the NS value. This is the total sample we have, right? So that means the number of sample space for this question is 100. That's the meaning. NS is equal to 100. Okay? That means the total number of samples for this survey, sample space is 100. Right. So let us try to answer the question. What is the probability if you choose one customer among this 100? What is the probability that the customer prefers Combank? Okay, if you choose one customer for 100, what is the chance that he or she will mention that he prefers Combank? Combank is these 26 of them prefer Combank. So this question is looking for probability com. So how to solve the problem? We can apply the formula that we learned today, right? This formula. We use this formula, the relative frequency probability formula, to solve the problem. Alright. So the formula is equal to NCOM divided by NS. So NCOM means in total how many customers among these 100 people Combank 26. So we substitute 26 for here. 100 is because total number of sample in the survey consists of 100. Okay. You may leave the answer in fraction number if you want, or you can leave the answer in decimal number. This number you can simplify becomes decimal number. Why? Because it's not a continuous number. If you simplify, get 0.26. Okay. If you don't want, you can simplify as fraction number also. Okay. So if the number can be simplified into finite decimal number, we just leave it here. If not, then we just leave the answer as a fraction number. So far, okay? Another example, is also apply the same concept. But now it seems to be the probability value given. Probability value given. So let us analyze the question first. So this question is, a garage sells from 0 to 4 car batteries each week. Based on past experience, the following probabilities are assigned to sales of 0, 1, 2, 3, or 4 batteries. Okay, so we have to understand first the meaning of this information. Okay, so what's the meaning of this one? That means that the chance of having 0 cells, right, per week is equal to 0.19. There is no cells, no battery cells. The chance of having 1 car battery cell per week is this number. Okay. The chance of having 4 car battery cells in a week is equal to 0.08. So if you sum up, you'll get 1. Why 1? Because these are the total probability chance to have the battery cells weekly. They'll get 1. So that means the information complete. 1. So now it is, okay, based on this information, okay, assume that A is equal to given that 2 or fewer of battery units is sold out in a week. So find probability A. Find probability A. This question is 2 or fewer. 2 or fewer. 2 or fewer will be this until this. Alright, these three events have car battery cells less than 2 or equal to 2. Right. So the solution will be 0.35 plus 0.24 plus 0.19. you get 0.78. So that means 78%, the car battery cells per week for this company will be 2 or fewer. 78%. Alright, B. Let B be the event that 4 or more. 4 or more. 4 or more means that X is greater or equal to 4. More. So we have to insert this. Right? This is the meaning. This one is probability X less than or equal to 2. B is probability X greater or equal to 4. Greater or equal to 4. So we have to include 4 and above. When the X is equal to 4 or above, so we check which class. Okay? Show the type battery cells is equal to 4 or above, only this class, right? Only this one. So you just put the answer 0.08. So far so good? Yeah? Next, okay. Let us analyze the question again. Example D. The probability that the post office delivers first class mail on the following working day after posting is 0.96. That means chance to deliver the mail on time is equal to 0.96. 0.96. Whereby the mail will be delivered on time by the post office. So if 93,500 first class letters are posted on Wednesday, so how many letters are likely to be delivered on Thursday? So this question is asking how many letters will be likely delivered successfully the following day? Okay, among these 93,500 samples of letters. So for this question here, we can just make some our equation. We can say that NS for this question is 93,500. The total sample, the total observed sample for this question is 93,500 letters. NS. And then we can use A also to represent. We assume that A means the mail will be delivered on time. Okay? Delivered on time, that means delivered successfully on the following day. So it's already given 0.96. So these two information already given to us. We are asked to calculate NA. How many letters are going to be delivered on time? Calculate this if these two information already given. So how to solve the problem? We still can apply the formula that we learned, but we need to transpose the formula. Transpose this formula. So what's the first step? You can write down the formula first. Take a lunch. This morning, write down the formula. Second step is substitute the number into each unknown variable. So PA already given, so you put here. This one, that's the M. And S also already, total number of letters already given. So now we want to calculate how many letters will be delivered on time. How many among these 93,500. So we transpose the formula. We move 93,500 to the left hand side because multiply. Move this to the left. Right? So that means how many letters will be delivered on time? 89,760 letters are expected to be delivered on time. So far, okay? So that means this question has understanding whether you know how to transpose the formula of this formula, so that you can solve the problem accordingly. Okay. So far we already learned one event. So in the real world we have more than one event, right? In the real world we have more than one event. So the next concept I'd like to introduce to you is involve more than one event. Okay, this is still one event. This is still one event. Okay. Besides the frequency, relative frequency formula that we learned, another formula that we need to understand also is complement rule. What is the meaning of complement rule? Complement rule believes that, right? Probability of event A plus probability of event non-A always equal to 1. Probability of A happen plus probability of A will not happen. Non-A means not happen. Okay? For event A is always equal to 1. So based on this rule, in fact, like, if you want to calculate probability non-A, this one means non-A, A won't happen, then you can transpose the formula. Okay, what you can do is you can just move probability A to the right hand side because minus. You see this? Okay. So this formula actually is from here. So if you want to calculate probability non-A, you can use 1 minus probability A. Okay. And we can also show the relationship, okay, among A, non-A, and also the NS by using a Venn diagram, because this is a Venn diagram. Right? So usually we use S, this is S, sample space. If this is A area, then outside the area will be non-A. The area of A plus the area of non-A always equal to 1. Overall here is equal to 1. The orange part, the whole orange part is equal to 1. The whole part is equal to 1. So A plus probably non-A always equal to 1. So let us try one example. So out of 50,000 components tested, so that means for this question we have NS equal to 50,000 NS. Total sample observed in this question is 50,000. So here I can just put an S right? Total sample been observed. So among this total sample, 48,700 were found to be working well. Okay. Then a batch of 3,000 components is delivered to be depot. Okay. So now this seems to be, okay, we use this one. Okay. So now let's say, okay, 3,000 components is delivered to be depot. So how many are likely to be not working well? So this question is asking, if we deliver 3,000 components, how many are not working well? Not working well, that means, okay, we can use PW bar, right, to represent not working well. So if you want to calculate this, we have to use the formula of 1 minus probability working well. Using this formula, right? Probability working well, how to get answer? You can apply this formula, right? So this N, W, and S. Okay. For this question, NW we have to use this one working well is already given. NS is from here, on the side 50,000. So simplify this. You may leave the answer in 4 decimal places if you want. We have to calculate the first the property for the component not working well. So simplify. So 1 minus this one, if you simplify, is equal to 0.974. So it's equal to 0.026. Right? So once you know the property not working well, then you can calculate among these 3,000 components, how many are not working well. So we go back to apply this formula again. We apply this formula. Right? Okay, so we have to transpose the formula, this formula. So PW bar is from here, right? Substitute from here. And as for this question now, actually, okay, we have to use 3,000. 3,000. So multiply 0.026, okay, 78. Okay. So among 3,000 components, 78 components are not working well. Okay. Next, intersection rule. What is the meaning intersection rule? Yeah? Intersection, in statistics, we use the symbol of this one to represent intersection. Something like N, but it's not an intersection. Okay. A and B intersect in which area? If even A and B intersect, let's say, meet each other. Intersect means meet each other. Two events meet each other. So where is the area? This is the area of A intersect B. When A and B intersect, meet each other, that will be good. Okay. So in this area, the proper area, event A and event B have similar elements, have same elements. That's what they mean. Because they share the same elements here. Same thing, same characteristics here. Okay. That's why A and B meet here. So this is the area. Union rule, what's the meaning of union rule here? Union, we use the symbol of U, something like U, union. Like this, So what is the area of union rule? Union rule, the union, okay, if A union B is referred to the yellow area, the whole area is referred to A union B. That will be the yellow area, alright? So what is the formula to calculate A union B property? Okay, you can use property A, which is this one, the whole thing here, plus property B, that will be this one, the B, right? And you may find that, right, actually A and B intersect here, right? In this area intersect. That means, like, this part is double calculated 2 times already, calculated 2 times. So we should only calculate 1 time only, So in order to address the problem, we have to minus property A intersect B. Okay? We have to minus A intersect B, because this area is overlap. Okay? So in order to address double counted problem, we need to minus this area 1 time. This area is equal to A intersect B. So in short, A union B is equal to A plus B minus A intersect B. So this is the only formula to identify A union B. So let us try one example. So let us analyze the question. So in a foundation studies of students, about 90% of the students pass mathematics. And 95% of the students pass English. And 88% pass both mathematics and English. So this is the A intersect B, is equal to 88%. So if a student is selected at random, what's the probability that the student pass mathematics or English, or means union? So this question actually is looking for the student that pass mathematics or English. Mathematics or English. So that's the meaning of this question. You are looking for union, property and union E. So what is the formula you can apply? Once you see the union question, immediately you have to apply the union rule. Okay? So union rule is equal to property M plus property E minus property and intersect E. Okay? And that is the formula derived from the union rule. This is okay for you? Union rule, okay? Alright, so now after we have identified, okay, the correct equation, the next is to substitute number into the variable. So PM means the chance of the student pass mathematics. So what is the value? Equal to 90%. 90% is 0.9. So put here 0.9. 90% means 90 divided by 100. 90% means 90 divided by 100. Okay. So it's equal to 0.9. So put here. So for okay, this one property E from here. So it's 0.95. So put here. So don't forget you have to minus property N intersect E. How to get answer? This one here. 88%. N. So it's minus 0.8%. So answer is equal to 0.97. So bear in mind, probability value must be in between 0 to 1. Cannot better than 1. That is the way you check the answer. I stop for a while. Any questions so far? I think you got questions. I think they have questions. If you have any problems, any part you can understand. Okay, alright. Then I'll proceed to the next question. Right? Okay, 3B. For 3B is some information given. These are the equation given. Okay, let us analyze the question first. Okay. This one means the sample space, okay? The sample elements. The sample elements consists of 1 to 10. We've got 10 elements, 10 numbers. Okay? From this sample. And then A consists of 4 elements, 1, 2, 3, 4. B consists of these 3 elements, 2, 4, 6. Okay. So based on this information, you are asked to calculate probability A union B. A union B, A union B, okay, you have to check, okay. That means union means like the number can be happen in A or B or both. I repeat, A union B means the elements that can be appear in either A or B or both. So there are a few ways to solve the problem. Okay. So how to solve the problem for this? You can apply this formula. So the formula is equal to number of elements, okay, for A union B divided by NS. NS is easier, right? For this equation, NS consists of how many elements? 10 elements. Right? A union B, we need to check. A has these, these are union. These are the elements from A. Right? 1, 2, 3, 4. B will have this, right? But 2 already appears, so we should count in one time. 4 also already appeared in A, so we just count one time enough. 6 only appears in B. Okay? So in total, so how many elements of A union B will be? This plus this. So get 5. That is one of the way you get answer. That is one of the way you get answer. Alright, if you cannot see the whole picture, what you can do is you can add one more step. You can add one more step. So there's another way. You can apply the formula that we learned just now. So we know that it's equal to PA plus PB, okay, minus A intercept B. We can apply this formula. If you don't want to use this method, you can apply this formula we learned this morning. Probability A is equal to 4 over 10, right? Probability B, 3 over 10. Right? Minus A intercept B. A intercept B means the elements that can happen in both A and B. Intercept means the elements that must happen in A and also B. So which are the elements that appear in A and B? Which are the numbers that appears in both A and B? 2, right? And what else? 4. So there are 2 elements, right? 2 elements for A intersect B. Then how about the D method? So simplify this. You'll get 5 over 10. So it's 1 over. So what's so good? So there are 2 methods for you to solve the problem. So you choose the formula that you prefer. Okay. Then how about this? Probability A intersect B. A intercept B, if you want, okay, you can use this formula. Probability, so this one is probability, so you can apply the frequency relative formula that we learned this morning, the first formula. So it's number of elements, okay, from A intercept B divided by number of elements for the sample. Okay, we check. That's not what we learned, right? There are 2 elements appear in A and B, right? So A intercept is equal to 1. And S is this one. 10. So simplify 1/5. You may also leave the answer in decimal number, you'll get 0.2. Also okay, acceptable. C. Property non-A. 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 So is we call as the complement rule. We have to apply the complement rule. So we'll deal with that property A plus property non-A. Always equal to 1, right? If you say non-A, that means, okay, first in mind, we have to apply this formula. Right? Then we transpose the formula. Transpose it to the right hand side. Becomes minus PA. Okay, now we have to get property of A. So A has how many elements? 4 elements. Right? So we have 4. Divided by what? Divided by total elements from the sample space. Okay. We get 3/5 or equal to 0.6, also okay. You can leave the answer in decimal number. Okay, D. D is V bar, property V bar. So using the same concept of complement rule, use the complement rule concept. Right. So property V bar means 1 minus property V bar. So property B, you have to check, okay, in B, how many elements? 3 elements. Altogether 3, so substitute here. And S is 10. Simplify is equal to 7/10. I probably you already learned this all these in your, maybe from 3 or from 4.5, or you learn. You just do revision today. So far so good. Okay. Then the next type of relationship that I like to introduce to you is called as mutually exclusive events. Okay? If 2 events are mutually exclusive, what's the meaning? That means like both events cannot happen at the same time. Cannot happen simultaneously. I repeat. What is the meaning of mutually exclusive events? Mutually exclusive events means the events cannot happen at the same time. Okay? So if A and B are mutually exclusive, if A and B are mutually exclusive, that means A and B cannot happen at the same time. So if you draw a Venn diagram, how does the Venn diagram look like? Okay, if you draw event A and event B for mutually exclusive, you may find that A and B never meet. Why? Because A and B do not have similar elements. That's why they never meet. Separate. Okay? Because A and B do not have same elements or same characteristics. That's why A and B cannot meet each other. So if this happens, we can conclude A and B are mutually exclusive. Okay. So for mutually exclusive event, you may find that the important characteristics for mutually exclusive is property A intercept B always equal to 0. Okay. There is no chance A and B will meet for mutually exclusive. So far, okay? Alright. If A and B is equal to 0, you may find that for mutually exclusive, property of A union B is equal to A plus B minus 0. Alright, for mutually exclusive, because A and B cannot meet each other. Okay, so there will be 0 chance to meet. So A intercept B is equal to 0 this time. If you simplify, you may find that for mutually exclusive, A union B is equal to property A plus property B. For mutually exclusive. So the important characteristic will be this one. You have to remember. For mutually exclusive. Okay, so let's try a few examples. Check, okay, whether you know how to identify whether the 2 events are mutually exclusive or not. First question. The activities involve swimming and sitting on like exam. Are we able to swim and at the same time doing the online exam? Can I? Swimming, okay, and then at the same time you need to do online exam. Quite hard, right? Highly not possible. Swimming and doing online exam, highly not possible. Can also now since we can, you can use handphone, right? So can do, right? But how to swim, I don't know. It's quite hard, right? If you think that these two events cannot happen at the same time, then we can conclude these two events are mutually exclusive. Cannot happen at the same time, that is mutually exclusive. Okay. Second question. Rolling score 3 and rolling 5 with a die at the same time. Is it possible to, when you draw a dice, you'll get score 3 and 5 at the same time? You throw only one time, throw only one die, right? Is that possible to get score 3 and 5 for this activity? Cannot, right? So answer is equal to not. This is mutually exclusive, so cannot happen at the same time. Mutually exclusive. Okay. Number 3, living in Kota Semarang and working in Kuching City. Is it possible? Possible, So that means these two events are not mutually exclusive. Are not mutually exclusive because can happen at the same time. Okay. 4, being under 21 years old and become Malaysian Prime Minister. Below 21, okay, and become Malaysian Prime Minister. Can these two happen at the same time? Cannot, because in the law of Malaysia, okay, those who are eligible to be Malaysian Prime Minister must be greater than 21 years old. 21 or greater. So these two events cannot happen at the same time. So we can conclude these two events are mutually exclusive. Mutually exclusive. Okay. 5, being a parliamentarian and a farmer. Okay. Can, can, right? So not mutually exclusive. Last one, drawing a red card. Okay, and that card is an S for a pack of cards. Red card and S. So can these two happen at the same time? A card which is red card and S. S will be this. Example, S is A, A is S card. So can I? It can be choosing this or this card, right? Both are red color and showing S also, right? So possible. So these two events are not mutually exclusive. Next. Okay, that will be the last concept for today. Independent events. Independent events, what is the meaning? Two events are independent. If a class of one event will not happen, the chance of another event happens. Okay? If I repeat, if A and B are independent, that means the chance of event A happen will not affect the chance of event B happen and vice versa. Okay? That means A and B will not affect each other if A and B are independent. A will not affect B, B will not affect A, then A and B are independent. Okay. So what is the important characteristics of independent events? If A and B are independent, then probability A intersect B always equal to probability A multiplied probability B. So bear in mind, this formula only applicable when A and B are independent. Independent means not depend each other. In means not. In means not. Not depend. Okay, so this is the important formula that you need to know, for independent events. Okay, okay. Another important formula that you may need is if you are asked to calculate a probability A, given that B happen, this slash means given. Given or if. Given. Or we call it as if. If B already happened, so what is the probability that A will happen? Answer is equal to probability A. Why? Because A is not affected by B. Even though we know that B already happened, the answer is equal to probability A. Okay? So this one formula is applicable when A and B are independent. Similarly also, for independent events, if we know that A already happened, so what is the probability that B will happen? Answer is still equal to probability B. Because B is not affected by A. So possible? So these are the main characteristics of independent events. So let's try some examples. So you may ask, then in the real world, what are the examples of independent events then? What are the examples of independent events? Examples of independent events would be maybe you're throwing two objects. Example will be because these two objects, these are two dice, but two separate objects, right? So if you throw these dice, red dice, the red dice result will not affect the white dice result, because these two objects are separate objects. So red will not affect white will not affect the red dice. So the experiment of throwing two dice are considered as two independent events, two independent activities. So we can apply the formula that we learned just now for independent events. So let's try one question here. Okay, this is just a simple one first. So we go for this one first. So this one is C and D are two independent, already informed, two independent. C and D, in which C is equal to this value, probability D is equal to this number. Okay. So find probability C union D. C union D. C union D. So what is the formula we have to apply if union? So no matter what is the relationship between C and D, no matter what is the relationship, if you see the question is equal union, immediately you have to use the union formula, the union rule. So it's using probability A plus probability B minus probability A intersect B, using this formula. Okay. This is the union rule you have to apply. No matter what is the relationship between C and D, you use this formula. Whether it's mutually exclusive, independent. Okay. Apply this formula. Alright. So what is the next step? Okay. The difference is only this part. Probability C intersect D. This is a problem here. So since the question already informed C and D are independent, so we can conclude that this part you can simplify is equal to probability C multiplied probability D. So this is the main characteristics for independent events. Right. Now the next is to substitute the number into each variable. So probability C already given, drop like put here. Probability D, this number. So put it. Probability C here. Multiply probability D from that question. Okay. So let's try to simplify this part. We apply the Botman's rule. Multiply first, right? You get 0.08. Then sum out and also subtract these numbers. You get 0.52. Okay. Next question. Probability C given D. So bear in mind, C and D are independent. Right? So if you are asked to calculate probability C given D, answer is equal to probability C. Right? Because C is not affected by D. So we apply this formula. So far okay for you? You know what is the result answer is PC? Yeah? So PC, the value is equal to 0.2. Substitute. So far okay? Okay, next. Let us analyze this question. This one, coins. Okay. Two fair coins are tossed. That means this question involves two experiments, two events. That will be throwing two coins. How many outcomes are there? How many outcomes are there? So this is the first question. Okay. Okay. Before we answer the question, we have to understand the meaning of coin. Right? We have to understand the characteristics of a coin. So this is example of coin, right? Cannot see. This is from Brunei coin, 50 cents. Alright. So this face is showing a face. So we call this as head, H-E-A-D, right? Because got the head of Sultan, Brunei Sultan. So this is head, right? And another face is called as tail, T-A-I-L. Okay? Tail will show the value of the ceiling. So for this ceiling is 50 cents. Okay? Or another example will be this, right? So this is the head. Okay, this is the tail one. So that means one coin has two faces. Two faces. So in this case, we can conclude that NS is equal to 2. Right? It's equal to 2. Either head or tail. So we can use H to represent head, T to represent tail. So if now you are throwing two coins at the same time, 2 coins, okay, at the same time. So what are the possible outcomes? The possible outcome can be the first coin will show head, second coin also head. Another outcome can be the first coin is head, second coin will show tail. Or the first coin is tail, second coin is head. Or both coins will show tail. Okay. So there will be 4 possible outcomes. 4 possible combinations where you throw 2 dice, 2 coins. That's one way. Another way is, what you can do is you can draw a tree diagram. Okay? You can draw a tree diagram in order to check how many possible outcomes are. Right? So how to draw? Okay, you have to start from the first coin. First coin has how many possible outcomes? 2, right? Either head or tail. You draw first, tree diagram. Right? Then move to second coin. Second coin, okay. So how many possible outcomes? Also 2 possible outcomes. Either head or tail. Right? Similarly, also for this is for the outcomes for second coin. After throwing the first coin, so it can be a head and tail also. So write down first. Right? So if you check from the tree diagram, how many possible pathways you may find it also got 4. Can be head tail, tail head, or tail. So 4 possible outcomes. So you can use tree diagram, or you can just show the elements like this in order to identify the number of outcomes. Okay. B. So how many of these have 1 head and 1 tail? So now this question is asking, among these 4 possible outcomes, how many outcomes got head and tail? 1 head and 1 tail. Check. So only these 2 outcomes got 1 head and 1 tail, right? Either this or this. So there are 2 possible outcomes. 2 that have 1 head and 1 tail. Okay, next. What is the probability of getting 1 head and 1 tail? 1 head and 1 tail, how is the probability? Then you have to apply the formula that we learned this morning, right? You have to use duster. The question is looking for this. Alright, so the formula is equal to number of outcomes that have head and also tail divided by total number of sample space. Total number of outcomes. So total number of outcomes got 4 possible outcomes. So how many outcomes got head and tail? 2. So put numerator here as 2. Right. So 2 divided by 4 you get 0.5. Okay, D. What is the probability of getting 2 heads? So to confirm both are heads. The first coin show head, second coin also show head. So how many outcomes got head? Only 1 outcome. This one only. This possible outcome only 1 got both heads. Okay. So answer is equal to 1/4. Okay. So this is the simplest number. You just leave it here. 1/4 or 0.25 also okay. Next. This question also involves coins again. Same question. Okay. Move on. Dice now. Okay, dice. So this question now is involve 2 dice. 2 dice. If you throw 2 dice, what is the probability of getting sum of the total score? Okay. You have to sum out the total score. This question is looking for total score for 2 dice. If you throw 2 dice, okay, what are the possible sample space? You throw 2 dice, what are the total number of possible outcomes? That's the question, right? So if the question involves two dices, my suggestion is immediately you list down these 36 possible outcomes. Okay? I repeat, if the question involves 2 dices, please try to list down the 36 possible outcomes. Okay? What is the meaning? That means the first dice may show score 1, second dice may show score 1, right? Or the first dice is 1, second dice is 2. Or first dice is 1, second dice is 3. etc. So list down first the 36 possible outcomes. That is first step, right? So that means there will be 36 possible outcomes, right? And S is equal to 36. If the question involves 2 dices. Okay, B. Find the property of getting a total score of 5. What's the meaning? That means like if you sum up the 2 score value from score 1 and score 2, you'll get 5 exactly. Total score 5 exactly. Yeah? So it can be 1 plus 4, right? It's equal to 5. Or it can be 2 plus 3, also 5. Or 3 plus 2 also 5 for this one. So there will be 4 possible outcomes. Okay, you'll get this answer. You'll fulfill this. 4 possible outcomes. So the numerator is equal to 4. How about denominator? Denominator, the question is equal to 2 dices. Okay, 2 dices, answer is 36. 36. So simplify this expression, can be simplified. You'll get 1 over 9. Use the calculator, make sure that you use the calculator to simplify this, to get the full mark. Okay, C. How is the probability that the total score is more than 5? More than 5, cannot equal to 5, but more than 5. What's the meaning? That means if you sum up the score from die 1 and score of die 2, the total value must greater than 5. That's the meaning. So what are the outcomes? It can be 1 plus 5, 1 plus 6, 2 plus 4, 2 plus 5, 2 plus 6. All this. All this will give you total score more than 5. So how many possible outcomes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 26 possible outcomes that fulfill this equation. So put 26. How about denominator? The question is involved 2 dices, so put 36. Simplify, 13 over. Another example of independent events will be like this. Okay, let us analyze the question, whether these 2 events are independent or not. Okay. There are 6 blue balls and 5 red balls in a box. So in total we have 11 balls. So for this question, in total there are 11 balls. So maybe I can use one of the color to show you. So I can conclude this. From this sentence I can say that NS is equal to 11. Total number of balls inside the box consists of 11. NS means the total sample of balls. Overall, 11. How to get 11? 6 plus 5. Possible? And what else can we conclude? NR. Okay, NR means the number of red balls in the box consists of 5. How about blue balls? 6. So we can conclude NB is equal to 6. So this information we can get on the first sentence. Right? Next sentence. 2 balls are randomly taken 1 by 1 with replacement. What's the meaning? 1 by 1 with replacement. Okay, assume that now there are 11 balls inside this box. What's the meaning of choosing 2 balls 1 by 1 with replacement? Randomly means, okay, I will not see this, okay, just randomly choose 1, okay? Right? Okay, red color, I jot down. This is the first ball that I chose, let's say. So I jot down the color is red, okay, jot down. Then I return. Return means I replace. Okay? The first ball in the box again. Means replacement. Return. Okay? After choosing the first ball, you return, then choose the second ball again. Okay? Randomly, it's still red. Okay, so this is the second ball now, it's still red. Also jot down the color of the ball, then I return. Okay? And that is the meaning of choosing 1 by 1 with replacement. Okay, the way of choosing these 2 balls are considered as independent events. Why? Because the first ball result will not affect the second ball result. Okay, I repeat. Okay, after choosing the first ball, you return, right? Before you choosing the second ball. As a result, right, the second ball is not affected by the first ball result. Okay, not affected. So the way of choosing these 2 balls are considered as independent events. Okay. First ball will not affect second ball. Second ball will not affect first ball. Independent events. Okay, A. What is the probability of choosing one blue ball and one red ball? This is the question, right? So this question does not specify the first ball must be blue and second ball must be red. No, it's only mentioned that either one of the ball is blue and another ball is red color. So you have to consider about the sequence, right? So for this question, in order to fulfill this, it can be the first ball is blue, second ball is red, right? Or also we use plus. Another outcome will be the first ball is red, second ball is blue. Also fulfill the requirement, right? So there are two possible outcomes for this question. So we use plus means another outcome, plus or. So let's try to solve this part. So what is probability? If you choose the first ball is blue color, answer is 6/11. How to get 6/11? Using 6 divided by 11. Get this number, yeah? Then you return the ball, right? Then what is the probability? The second ball is red color. Answer is 5/11. Why is 2/11? You may ask, how come second ball is 2/11? Because after choosing the first ball, right, you return the ball, right? So when you choose the second ball, the total number of balls inside the box is 2/11. Right? This is the denominator, the NS for choosing the second ball is 2/11. Remember, right? Because after choosing the first ball, we return the ball inside the box. So when choosing the second ball, it's still equal to 11 for the NS. Okay, so what is the probability of choosing the second ball is red color? Answer is 5/11. Okay, now move on to second outcome. What is the probability of choosing first ball is red color? Answer is 5/11. Then return the ball. So what is the probability? The second ball is blue color. Answer is 6/11. So bear in mind, for the second ball, the denominator is still equal to 11 because we return the first ball, right? Before choosing the second ball. So the denominator for the second ball is 11. Okay, so let's try to simplify these two terms. Right? Simplify this is equal to 30/1 to 1. 6 multiplied by is 20, right? 11 multiplied by 11, 1 to 1. How about this one? Also 30/1 to 1. So sum up the numerator because the denominator are the same now. Sum up will get 60/1 to 1. Okay. If this is the simplest form of fraction number, we just leave it here. Okay? Don't disturb. Don't change to decimal number because this is going to have the rounding error problem. So just leave it here. Okay? B. Okay. If you choose two balls one by one with replacement, so what is the probability that okay, at least one of the ball is red color. At least one is red color. If that's the case, there will be three possible outcomes. It can be the first ball is blue, second ball is red. Because this outcome fulfilled. This requirement fulfilled. Another outcome can be first ball is red, second ball is blue also. Okay. Or another outcome is both balls are red. Okay. If both colors, both balls have the same color, they will just count one time. I repeat. If both balls have similar color, then we should only count one time. Okay. So some students may ask, why don't we just put like this? Like this? No need, because we double counted if that's the case, right? If both balls are same color, just count one time, enough, right? Because both balls have the same characteristics. So only count one time, So far, okay, this part. Okay, then the next step is to simplify, Simplify each outcome, So these two in fact are from here, right? These two. So it's okay. Then how about here? This one, the third outcome, red. So what is the probability? The first ball chosen is red color, 5/11. Then we return the first ball. Choose the second ball. What is the probability? The second ball is red again. Answer is 5/11. So simplify. So this part you'll get 25/1 to 1. Sum of these three terms, you'll get 25/1 to 1. Okay. So the important information for this question is make sure that we just count one time only. When the combination of balls, okay, for both have similar color. Okay. A similar color, we just count one time. Okay. C. What is the property of choosing two red balls? Two red, conform. First ball is red, second ball is red, conform. Okay. So that means only one possible outcome. Both balls are red. Okay. So first ball is 5/11. First property, the second ball is also red, 5/11. And simplify is equal to 25/1 to 1. Okay. Next, D. Yeah. What is the property of choosing two balls with similar color, same color? Confirm two balls have similar color. So for D is looking for property of choosing two balls with similar color. Confirm, okay. So what are the possible outcome? It can be both balls are blue color, or also we use plus, or that means we use plus, or both balls are red color. This or this happen. Okay. So what is the property of choosing? The first ball is blue, 6/11, right? So we return the first blue ball inside the box. Choose the second ball. What is the property of getting blue color again? 6/11. Okay. So for this part, you have information from here. Okay, see. So you can just duplicate the information. So simplify again, 61/1 to 1. So far, okay? So in short, independent events are the events that will not affect each other. Okay, so what are the examples of independent events? Throwing two coins, throwing two dice, throwing one die and one coin. Okay, or choosing two balls one by one with replacement. These are the examples of independent events. So for independent events, there are three formulas that you need to understand. For independent events, these are the important formulas that you need to apply. Okay. So in short, what we have learned today. So today we already learned the definition of property. What is property? We already learned, right? We also learned the basic formula that you can use in order to solve the problem of property by using the relative frequency rule. Relative frequency rule means this one. Relative frequency rule is using if you want to calculate property A, then the formula is equal to NA divided by NS plus, right? So this formula is called as the relative frequency rule. You also learn the complement rule. Complement means, what is the formula we learn? Complement means property A plus property not A always equal to 1. Complement rule. Complement means A plus not A always equal to 1. Intersection rule, what is the meaning intersection? Intersection means this one. Union rule is A union B. So what is the formula we learn? A union B is the formula. Remember? A union B, what is the formula we learn? No matter what is the relationship between A and B, A union B formula always the same. Formula is A minus so we apply this formula for A union B. The difference is only this part depends on the situation of A and B relationship, right? But we always apply this formula. Mutually exclusive means A and B cannot happen at the same time. So what is the important characteristics of mutually exclusive? What is the formula that you need to get ready when solving the problem for mutually exclusive event? A union B is equal to A intersect B is equal to what for mutually exclusive? Multiply. No, mutually, okay, let's say this. Mutually exclusive. Mutually exclusive means A and B cannot happen at the same time. Then what is the formula to calculate A intersect B? What is the value? 0, right? Because A and B cannot have at the same time. If independent events, I use other color lah. I use purple. If independent event, then what is the formula to get independent events of A equals E? Probability A multiplied probability B. So these are the formula that you need to know, yeah, for today's lesson. And we still have one more event that will be covered on Thursday. There will be dependent event. So before we go for a dependent event, make sure that you are clear with all these basic concepts of probability. So how to make understanding? You have to do the exercise, alright? So try to complete exercises one by one and one by two. Okay. You have to go to the canvas side and then open the exercises. Try to do as many questions as possible. Right, so these are the questions. So go back home, try exercise 2.1 until 2.2. Possible try to finish all, so that tomorrow we can do discussion. Anduka, you have to just stop the recording. Any questions on probability before we call it? Please, you still have about 10 minutes.